Alright, so we're talking about normal distributions today, kind of get into our lesson. Just a couple key things I'd like you to understand from it. So here's a nice, what we call a normal curve, sometimes called a bell curve. It actually comes from this. So this normal curve or a normal distribution is found all over in nature. If we graphed heights of people, weights, all kinds of things, foot lengths, all kinds of things out in nature, you find they have a normal distribution. Right in the middle is the average, okay, the mean, and these representations, this is one standard deviation from the mean, 2 standard deviations, 3 standard deviations, and then of course we go below 1, below 2, below 3. Now you could get things farther out, but most of the data, most things are going to be within this normal curve, okay? A couple things I want to point out here, and this is broken down in percentages. It goes like this: 68, 95, 99.7%. So within one standard deviation, one goes above, one goes below, you've got about 68% of all the data in a normal distribution. Within 2 standard deviations, okay, if I added 68 and 27, we get 95% of all our data. So within 2 standard deviations, you get 95% of all your data in a normal distribution. And if I go 3, let me just drop down below here just so I can show it. If I went all the way out here, within 3, I've got 99.7% of all the data falls within 3 distributions. So there's only a tiny, tiny percentage that goes beyond 3 standard deviations, okay? And you're going to use this a lot as you go through this lesson. Here's a little example. Use the normal curve shown, identify the mean and standard deviation. So let's look. Well, the mean is right here in the middle, okay? So 54.2. Standard deviation, well, here's a value, 1 standard deviation above. So if I did 66.5 minus 54.2, in fact, I'll just do it right here, so it's easier. So there's a 3, there's a 2, so it looks like 12.3 is our standard deviation. So here's our mean, and 12.3 is the standard deviation. Hey, looks like B is a winner, okay? So that previous curve just had a 0 here and a 1 and a 2. We call that a standard curve, where it just makes, it's basically a z-scores on the bottom. These are actual just raw data values. Okay, how about this one? A set of data with a mean of 62 standard deviation is normally distributed. What is the value -3 standard deviations from the mean? Well, so I want you just to picture it. If 62 is right here in the middle, if we come over 1 standard deviation, over 2, over 3, in the negative direction, where would we be at? Well, we would subtract 5.7, subtract 5.7, subtract 5.7, and we'd be out here at 3 standard deviations. Does that make sense? So we're going to do 62 minus 3 times 5.7. Let's see what that gives us. I'll bring up my calculator here just so we can picture that. So 62 minus 3 standard deviations, each one was 5.7. Okay, we get 44.9, okay? So again, looks like B going to be a winner there. They could have said, hey, plus 2 standard deviations, plus, well, you just go the opposite direction, plus 2 times 5.7. How about this one? Set of data has a normal distribution, mean of 5.1, standard deviation 0.9. About what percent should fall between 6 and 6.9? So again, I see a 0 here. Let's go ahead and put in our mean. So this is 5.1 right in the middle. Standard deviation is 9. So if I added 1 standard deviation, that would put me at 6.0. This would put me at 6.9, right? Plus 0.9, plus 0.9. About what percent of data is between 6 and 6.9? Well, here's 6. Here's 6.9. Hey, 13.5% of our data. So it looks like D there. What if they had said in between 5.1 and 6.9? Well, then I'd add 34 and 13.5. What if they'd said in between here and here? Well, you can add from this graph. So that's just using, again, this relationship, and they'll give you the graph. It's got those percents. Okay, you don't need to remember that at this point in your mathematical career, but just want to kind of introduce it, give you an idea how we can work with these things today.